Depending on the structural member, the type of application can be selected from the application menu. Under the Geometry tab, you are able to select the concrete's grade using imperial or SI units, with the possibility of a user-defined concrete compressive strength input. In addition, the dimensions of the member could be adjusted under the same tab or directly on the 3D model, with a dynamic utilization display for the unstrengthened section. For the boundary conditions, a simple beam approach is presented, with further support types under development. Similar to the Geometry tab, the user is able under the Reinforcements tab to input the steel's yield strength, with a user-defined elasticity modulus input too. Concrete covers are input to calculate the effective depth. Both upper and bottom reinforcement layers are displayed by default, with options to adjust the number of bars, rebar diameters, and effective depth. Further reinforcement layers could be added to the section, including the adjustment of the same parameters mentioned shortly. The software also notifies the user when input values are outside the acceptable limits. At the same time, the utilization of the unstrengthened section is recalculated as seen below. For shear reinforcement, the stirrup diameters can be given, with the spacings adjusted in the tabular input, as per the section's reinforcement. Input changes are directly reflected in the dynamic utilization bar, whether for the unstrengthened or the strengthened utilizations. Moving on to the loads input, moment and shear loads are entered separately with two default load cases and a minimum unstrengthened limit load case. Along with the loads, load factors could be adjusted to the user preferences. Additional static or quasi-static load cases could be added to the strengthening calculations depending on the design requirements needed. Reaching the strengthening step, flexural strengthening is by default defined under the strengthening type, with shear strengthening as an option selected if needed. For flexural strengthening, the Fisher C-Fiber Force Assortment provides two strengthening options for flexural: CFRP laminates or CF fabrics. For the Fisher CFRP laminates, depending on each case, the user can choose between the standard elastic modulus, S, or the high elastic modulus, H, each available in 6 different dimensions that could be selected and illustrated on the 3D model with immediate result display. Additionally, number of plies and laminates are adjusted depending on the strengthening requirements, as well as the reduction factor for environmental exposure. Still in Flexure, the Fisher CF fabrics are available in 2 FRSW products with the designation U300 and U600, differing in fabric thickness and area density. Both products come in 2 dimensions that are prepared and installed using the FRSCF saturating resin. The same product is used for shear strengthening too. Once selected, tabs related to shear strengthening become active and strengthening could be proceeded as demonstrated here. A rectangular beam can be strengthened for shear using a closed or open wrapping schemes. Also, a full surface or partial wrapping is selected depending on the degree of strengthening needed for the beam. And as already mentioned, dimensions and plies input are flexibly adjusted by the user. The user can anytime control the visible outputs in the 3D model to ease with the design under the View tab. Finally, a printout could be issued as a PDF document with different selectable languages in a short or full report form to look into the calculation steps in detail.